Today we're going to be talking about differential equations and slope fields. And I kind of do a little bit of an introduction to differential equations. We talked a little bit about them in the last chapter. We're just kind of going to continue on what we were doing in the last chapter, and we'll talk about slope fields today. So a differential equation is an equation involving x, y, and the derivatives of y. So a differential equation here, you have the derivative hanging out as part of your equation, okay? A general solution doesn't have a differential equation, but it's going to have a constant, and a lot of times we're going to be calling for that. We're going to be solving for that constant. And then the order of our differential equation, okay, so first order would be a first derivative. A second order differential equation is a second derivative. And in college, it's usually after you take a Calculus 2 class, if you're going to take a lot of calculus in college, there's a whole DiffEq class, differential equations class, that you can take. And they go into a lot more depth than we're going to do. This is just kind of an introduction. So we have a differential equation here, and this is the general solution to that differential equation. And then you have all of your possible solution curves, and that depends on what C is, okay? And a lot of times, we're going to be solving for C. And throughout today, we're going to be drawing in some of these solution curves, depending on what point or initial condition I give us. Okay, for this differential equation, verify that y equals c e to the negative x squared is a solution. Then find the particular solution determined by the initial condition y equals 2 when x equals 0. Okay, so we have two things to do here. Looking at my notes, there's two parts to my notes, and I didn't remember that there was two parts to my notes here. Okay, so what you want to do to verify is find the derivative of this function and plug into our differential equation. So y prime is equal to c e to the negative x squared. Then I take the derivative of that, which is, by that I mean the exponent, negative 2x. And I plug into this differential equation. So I plug in negative 2x c e to the negative x squared. Okay, so that was the y prime that I'm plugging in to that piece, plus 2x. What's y? Y is this quantity here, c e to the negative x squared. I have two of the same terms, I'm subtracting them, so I get 0. So yes. Now we want to verify, or we want to find the particular solution, so our particular curve. And we have the condition y equals 2 when x equals 0. So plug those points in. Plug in 2 for y, e to the 0 power is 1, so c gets me 2. So my equation ends up being that equation there. Okay, find out functions y that satisfy this differential equation. Okay, finding all functions y means I'm going to have a constant of integration that I'm going to have to deal with. Now, I solve all differential equations by what we call separation of variables. And I don't know why the book doesn't do this. I think I know why the book doesn't talk about separation of variables for a few later sections. But what I do is I multiply both sides by dx. It's probably not the most mathematical, probably not the best calculus-y type of thing to do. You're not really multiplying, but that's how I can justify it in my head. Basically, what separation of variables is I get everything that has a y on one side, everything that has an x on the other, and then we integrate both sides. So the integral of dy is y. Integral of this right side is x cubed plus sine of x plus c. So that separation of variables I was talking about is just multiplying and getting everything that has an x in it next to the dx, everything that would have a y in it next to the y. Directional fields. I'm going to be calling these slope fields. Just a book that I stole this picture from called them directional fields. So directional fields, also known as slope fields, enable us to sketch the solutions of differential equations without knowing what the formula is. Okay, so it all depends on the initial condition. So like they might give me this point as my initial condition, and I'm going to be able to draw in what my curve looks like. I might have this point here as an initial condition. So that's what that curve would look like. I might have this point up here as an initial condition. So you would have a different curve. So it all kind of depends on that initial point that you're given. Now, if we were to solve this differential equation using our initial conditions, so dy dx equals x plus y, and I like this idea of separation of variables. So there's no way for me to separate the variables. If I multiply both, or if I subtract the y over, I have dy dx minus y is equal to x. Then I'd multiply by dx. Then I'd have a dx here. So there's no way that I'm going to show you guys how to solve this unless we use what I call, and what a lot of calculus teachers call, a slope field. Okay, so a slope field. And I use this, typically I'm going to be using this grid. Remind me during class, I'll give you guys some slope field graph paper. And the book has larger ones. It talks about larger grids. I just stole this from the old textbook. Kind of gives an idea of what you might see on the AP. So what I do here is set up for each one of these points. For each one of these points, set up a chart, and you plug in -1 and -1 for x and y, and you get a dy dx value out. So that's a slope of 1. So at the point -1, -1, what you have there is you have basically a little tangent line that you're drawing in, because the tangent line is going to tell you the direction. So a slope of 1, I think about it, looks like it's at about a 45-degree angle. So something like that. So then I have here -1, 0. I have a slope of -1. So this slope is a negative sloping. I look at it like it's a 45-degree angle. -1, 1, we have a -3. So a negative sloping line, but a little bit steeper. And then when I plug in -1 and 2, we get a -5. And then something that's even steeper, but you don't want to have it be horizontal, because a horizontal would mean it be an undefined slope. But they have to look like they're either positive or negative, and like for these three, they're increasing in slope. What I might do, I might erase this guy and make this guy, adjust this guy a little bit so he's not the 45, he's not as high as the one I have up there, he's somewhere in between. Okay, continuing along. If I plug in 0 and -1, I get a 2. And so, okay, so a positive slope, but a little bit steeper than that one. Looks like about the same. Then I have at 0, 0, I have a 0 slope. Remember, 0 slope is a horizontal line. And then at 0, 1, I have -2. So approximating. And 0, 2, -4. So not as steep as my -5 slope, somewhere in between those. And I'll talk about how I'm going to grade these here in a minute. Let me fill in the rest of the chart. 3, 1, -1, -3. Plotting my points. So a little bit steeper of a slope. I have a 1 slope. I have a -1 slope. And a -3 slope. Okay, what I'm going to be looking for, okay, I'm going to be looking for the chart, and I'm also going to be looking at, okay, any slope that should be zeros, any slope that should be 0, 0. Yes, right there. Any slope that is negative, are those negative? Yes. And do they look like they're maybe increasing a little bit? Yeah, I don't know exactly perfectly what they are, okay? And you don't have to worry about that. And you don't have to label what these slopes are on your slope field. It just gives me an idea of the curve, okay? Okay, so that's the idea of a slope field. Again, what these are little tangent lines. I didn't make that super clear. These are little tangent lines, so it gives me the direction, an idea of the direction, so that maybe eventually I could draw in some sort of curve, just guessing. Okay, I can't solve this. Probably if you take a differential equations class in college, they'll teach you how to solve this, but I don't know how to solve that for right now for everything I'm going to teach you. Okay, a lot of times on multiple choice, you're going to have to match the slope field with the differential equation. Okay, so let's look at these. And look at these slope fields and notice how, to me, it looks like A and C are very similar. Okay, and A and C are very similar, so B is kind of the outlier. Which equations? 1 and 2 are very similar. 3 is kind of an outlier. Y prime equals 2x. I mean, even if I solve that, I would see that it is it would end up looking like a quadratic. But whenever I plugged in x equals 0, my slope, dy dx, would equal 0. So kind of look for those zero slopes. My zero slopes are here, so I know that this one goes with B. Okay, now look and see where we have a zero slope. It looks like I have a zero slope here at the point that would be 1/2, 1. Okay, so I'm just going to do some quick checking. If I plug in 1/2 and 1 here, and sorry, I'm looking at my notes and I don't understand what my notes are. When I plug in 1/2 and 1, 1/2 and -1, that's why my notes are wrong, I would get a slope of 2. So I know that this is not it. Let me check it here in this one. If I plugged in 1/2 and 2. So if I plug in 1/2, so 2 times 1/2 minus 1, that gets me a 1 minus a 1, that's a 0. So this looks like this goes with A. And then let's just double check. It looks like I have a zero slope here. It looks like I have a couple of them. A zero slope here at 1/2 and 1. 1/2, and when I had a positive 1 there, remember that changed me a little bit. 1/2, and then when I was at a positive 1, that got me a slope of 0. So right away that's C. So you kind of have to look for where you might have those zero slopes and plug in those points. And you might have to look and see, oh, it looks like with every one of my x's, they're all staying the same. Okay, or they're changing with the x's but staying the same with the y's. That's how I knew number 3 was B. Okay, so it's just a little bit of trial and error. Okay, I took this example from the book and sketch a slope field for the differential equation. Use the slope field to sketch a solution that passes through the point 2, 1. Now, it would be a really long video. I'd probably take about 15 minutes to try and plot all of these points. So what I actually did is I stole a solution or a slope field from online, okay? Because the key point that I want us to do is I want us to look at what this slope and how you would sketch in that solution curve. Okay, now like if it was a regular classroom and we were regular school year, this is 2021, you're going to be watching this video. I would have you guys do this one first on your own, but for now, that's what the slope field would look like. And I just stole that from a program that I know online that builds slope fields. It's a pretty easy program. You could Google it and find it. Okay, but the point is that we want to sketch the solution that passes through to -1. So let's look at what our dy dx, or our slope, is at that point. So if I plug in 1 minus 3 times 2, I get a 1 minus a 6. That's a -5. So here at 2, 1, because this is where my initial point's going to be, I have a slope of -5. So that means I would go up 5 units over. So that's a pretty steep curve. Okay, so that's a pretty steep curve I'm going to approach. So it looks like I have a pretty steep curve down that way, a pretty steep curve up this way. Looks like it eventually goes to 0 at some point, and then comes down, and again is pretty steep. Now, I struggle with kind of drawing these, and my students always ask me every year is, well, how do I know exactly where it is? Look at the steepness around this graph. So maybe if I had a little bit bigger of a slope field, I would go up 5 over 1. That would get me, that's technically a slope of -5. And look, it looks like it's going to 0. So I know somewhere up here I'm going to 0. And then it looks like I'm pretty steep down here. I might plug in, if I plugged in the point, 0, 3. If I plug in the point 0, 3, I get 3. That doesn't make any sense. Okay, yeah, because that is a positive slope. That is a positive slope. Duh. So I know I would go from this point, or wherever I kind of hit, I would go down 3 over 1, and that's how I knew I might be about right there. Okay, it's about the best approximation you can make. I know I wouldn't hit this line up here because that doesn't make sense for this slope. This is a pretty steep slope. It's a slope of a -5. So I need to go up a lot and then come back down. Okay? Okay, so that's your introduction into slope fields and drawing those curves and a little bit of differential equations. I hope you enjoyed the video, and make sure you have everything ready for class.